Okay, ladies and gentlemen, today we're going to talk about compounds and formulas. Quick review, what is an element? Remember, an element is a substance that cannot be broken down chemically any more than it has already been broken down. It may be able to be broken down physically farther into smaller and smaller pieces, but chemically you cannot break it down any more and get anything different with different chemical properties. An element is made up of only one type of atom. Elements are organized using the periodic table. And some examples would be Na, sodium, Cl, chlorine, O for oxygen, O2, which means you have two oxygen atoms put together. This is still an element because even though you have two atoms, they're the same type of atom. And C8 would be 8 carbon atoms put together. Again, still an element because you have 8 of the same type of atom put together. Now, just a quick review as well. These first three, remember, would be atoms. These last two would be molecules because they have more than one atom, okay? But they're all considered to be elements. What is a compound? We've talked about this a little bit in class. Compounds are two or more elements that have been chemically bonded together. A compound ends up being a brand new substance that is made when the two elements chemically bond. The substance is brand new. And finally, the new substance has completely different properties than the original elements that made it. The best example here, guys, is water. Water is made out of two hydrogen atoms and one oxygen atom chemically bonded together, H2O. Now, hydrogen all by itself is a gas, and it's highly flammable. Okay? And you couldn't possibly breathe it in. If you did, you'd probably die. Oxygen is also by itself a gas. You can breathe it in, but it's also pretty flammable. But when you take hydrogen and oxygen, two hydrogen, one oxygen atom, and you chemically bond them together, you end up getting water. And water is a liquid, and it's not flammable, and you can't breathe it, but you can drink it. So it has completely different properties than the two elements that made it, basically to make it up. So what are chemical reactions and equations? Well, when two or more substances chemically bond together, like elements bonding together to make compounds, we say that a chemical reaction has taken place. A chemical reaction has two parts. There are the reactants. Those are the substances that go into the reaction. Basically, they're the things that you have before the reaction takes place. We call them reactants because they're going to react to each other chemically. They're going to have a chemical reaction. And then you have the products. The products are the things that come out of the chemical reaction. Okay? They are basically the substance that you have after the chemical reaction takes place. We talked about this a little bit when we talked about photosynthesis. The reactants for photosynthesis are water and carbon dioxide. And the products for photosynthesis are oxygen and glucose. Okay? So the reactants go in, the products come out. There are two ways that you can write equations. There's word equations that are written in words. Again, for photosynthesis, it's a good example. That would be saying carbon dioxide plus water yields glucose plus oxygen. Okay? And then you have chemical equations. Those are written in symbols. The example for photosynthesis for that would be 6CO2 plus 6H2O yields C6H12O6 plus 6O2. So you have word equations and chemical equations. Now, there are some rules for naming compounds. Compounds, when you read the names of them, they have very complicated, fancy sounding names. But basically, if you follow these rules, you'll be able to tell what the compounds are, even though they have these fancy schmancy names. So, first of all, the first part of the name in a compound is usually the name of one of the elements that's in it. For instance, I'm going to use this example a lot. Carbon dioxide. The first name is carbon, and the compound has carbon in it. Okay, so that's like the first rule. That's the easiest one. The next rule is that the second part of the name usually has a piece of the second element that's in the compound. Again, I'm going to use carbon dioxide as an example. The first name is carbon. The second name is dioxide. The ox part stands for oxygen. Okay? So the second part of the name has a piece of that element in it, ox, for oxygen. The third rule is that if an element is not connected to other elements in the compound, then they put an IDE on the end of it. So if it's the very last name in the compound, it's the last one, it's not connected to anything else farther down, you'll see an IDE in it. My example here is iron sulfide. That is basically made up of iron plus sulfur, and since sulfur is the last name that's inside this compound, they add an "ide" onto the end of it. So this is basically iron plus sulfur is iron sulfide. Okay. Now, another rule. If you have one atom of the element that's joined to an atom of the first element, and there's two of them, they'll use the prefix di. That wasn't written very well, but let me explain it. It'll probably be better or easier. For instance, here's our example again. Carbon dioxide, the di stands for 2. It's the prefix for 2. So dioxide means that you have 2 oxygen atoms in it. So carbon dioxide is 1 carbon atom and 2 oxygen atoms. If something has 3 atoms in it, they'll use the prefix tri. So for instance, I don't think this is an actual compound. I'm making it up. But if we had carbon trioxide, that would be 1 carbon and 3 for the prefix tri oxygen atoms. Okay, so tri stands for 3. Next rule is sometimes you'll see the prefix mono on something. Mono means there's only 1. Okay? So for instance, carbon monoxide means there's 1 carbon atom and 1 oxygen atom. Mono stands for 1. So mono stands for 1, di stands for 2, tri stands for 3. Okay? I know what you're thinking. I can sense it. You're saying, Mrs. Sullivan, what would be 4? Okay, 4 would be like quad, but you don't usually see 4 very often. It usually goes up to about 3. So don't worry about 4. We're only going to go up into class to 3. Okay? But 4, I believe, would be like quad. Okay? If there are 2 elements joined to the next rule, if there are 2 elements joined to the first named element, a name may be made up of their 2 names. So for instance, here we have sodium hydroxide. So this is sodium atoms plus hydrogen atoms. Hydro stands for hydrogen. Plus oxygen atoms. And remember the IDE on the end is just there because it's the last word. So sodium hydroxide is sodium, hydrogen, and oxygen. Last rule, and then we can pack it up for the night and you can go play Xbox or something. The suffix ate on the end of a word stands for oxygen. Okay? So if you have ate on the end of something, it means there's oxygen atoms with it. So for instance, calcium carbonate is made out of calcium and carbon and oxygen. The 8 stands for oxygen. In fact, the symbol for this would be CaCO3. Okay, so calcium, Ca, plus carbon, C, plus O3 is oxygen, calcium carbonate. I know what you're thinking again. You're thinking, Sullivan, it has 3 oxygen atoms. Why in the world didn't they call it calcium carbon triate? It just doesn't work that way. I don't know why they didn't, but it just doesn't work that way. But I can tell you the ATE on the end stands for oxygen. Ladies and gentlemen, that's it. Please bring your notes to class, and I hope you have a good remainder of your day.